Hello friends, in this video we are going to discuss about TensorFlow. TensorFlow is a machine learning library like sklearn, Keras, Piano, PyTorch. But this is little famous. It was introduced by Google Brain team and released as open source in 2015. And TensorFlow 1x version, there is some complexities available. So most of the machine learning developers, they will not be using TensorFlow directly. Instead of that, they are using Keras API and the wrapper of the TensorFlow 1x, and they will be utilized. But in TensorFlow 2x will be a combination of TensorFlow 1x and Keras API. And directly you can interact with your data without any session. That is called as a eager execution that they will be given in TensorFlow 2x by default. Before discuss about TensorFlow, we just know what is Tensor. Tensor is a n-dimensional data. That is, we are going to handle it via this library. So I have given some example. If it is a 0 dimension, then it's called as a scalar, which means a single value. If it is a 1 dimension, then it's called as a vector, which means all collections of the programming will come to vector. And 2-dimension tensor is a matrix, which means row and column is available, then we can utilize it. And there is a lot of other tensors are also available, 3D, 4D, like I have given some example. We just discussed about the installation. So if you want to install the TensorFlow, you can use pip install TensorFlow. Or if you want to install with any specific version, you can mention it. I'm using TensorFlow 2x version. We can see that version here. I'm using 2.1.1 version of TensorFlow. We can see some example with that. So this is a 0 dimension data. I just declare as a constant value with only one value, which is a scalar. Here it will be declared as a 0, and this is the value, and this is the shape of the value, and what is the type of the data. These all will be declared. If you want to retrieve that only shape or d type, you can call the method with that variable. Example d.shape, d0.shape, d0.d type something. Then you can pick up this record separately. Next one is vector, a group of data that is, I'm going to store it here. You can see this value is a group of data. I can store it, and there's a shape of this value in 1 dimension, and it will be stored as a float values. Likewise, 2 into 2 as a row and column matrix, I'm going to store it. Here is an example. Likewise, you can go n dimension of data. This is a 3 dimension of values I just declared, 2 into 2 into 2. So 2 element with the 2 row and 2 column. That is the meaning for this shapes. There is a multiple bit of data type is available with the same data type name. Here are some examples available. Based on the bit, you can declare your data type. So I just declared 0 tensor and a 3 dimension sensor for the example. So here you can see the 0 tensor value will be showing to you as a 0, and it will be providing with the integer values. So difference between the variable and constant. Variable you can change, but constant you cannot change it. Once you declare the constant, you cannot change any time, but both will do n dimension of data handling. Here some example. I have already declared x1 value as a variable. This is will be stored as a 23 as a value. Now I'm supposed to change the value via assign function. Now it's changed to 100, but the same I'm trying to do that. I just declare as x1 with constant as 100, and I'm trying to change it. It will not be allowed because attribute error will be throwing due to the constant declaration. So some other data type values available. You can see this. Next, reshape. Once you declare the variable, you want to reshape it. That is also possible. Here you can see this one. Yeah, this is the value. This value you want to reshape it. I just using the same variable as x2. This value already in 2 into 2 into 3 matrix is available. Now I am supposed to change into 1 row and 12 column. That I am going to declare it. So this is the entire 1 row with 12 column will be available. If suppose I want to change into 12 row and 1 column, that is also possible. Likewise, you can declare and reshape your values with new variable. Next, declaring a variable with type, that is also possible. Here I just declare the value with the 202 as an integer, but I just mention as a float value. Now you can see the values 202 as a float. Likewise, you can do it. Ranking is very important thing. In the beginning also we have seen the dimension of the value via ranking method only. So ranking will help to find the variable of dimensions. So mostly whenever you're doing some TensorFlow multiplication or any operation, the output, what will be the dimension of data you'll be getting in. That information you can collect from ranking. So x64 is a 0 dimension, I think. Yeah. Now I just check this one. There is a value, it will be declared here. Numpy 0 means 0 dimension. Suppose x2 variable available with 3 dimensions of data. This 3 dimensions of data I'm going to retrieve here. Yeah, it will be mentioning as a 3 dimension. So which help to identify which dimension of data you will be getting it. That is the use of ranking. Here some example for constant also. I just declare as a 3 dimension of data and I can retrieve it. This is the sample for this constant value. Next, slicing. Slicing helps to slicing your data and pick it up a particular value between this matrix. So here I just mentioning the t value. This t value I'm going to retrieve 1 to 1 into 2. We'll see that with some clear example. So here this is the first value. So which means this is a 0 element, this is the first element, come out, and then it will be first row. This is a 0 row, this is the first row. So this row will be coming out, and then second column. So 4, 4, 4, 1, 4 is the value. In this, there is a 0 column, this is the first column, this is the second column. I just refer for second column. So this is the value that will be reflected here. You can see. Likewise, tensor slicing is possible to pick it up your particular values. Also, like pandas, you can retrieve the data between the indexing values. That is also possible. Here some example I have given you. Like casting also we can do it. I supposed to declare everything as an integer value, but I am trying to convert it to the float data type. You can see here. Next, tensor operation. We can see some aggregations between the tensor via this tensor operation. I just declare two variables a and b with some value. I just going to aggregate that, and this is the value. Now I'm going to do the additions of a and b. That's a C value matrix. We'll see the output here. Yeah, it's based on the indexing. It's just going to be added the values. So 1 and 5 will be in the 0 index. It will be added and giving us 6. Likewise, all other matrix will be calculated and giving to you. Likewise, square is available. Based on the square, I can aggregate the square matrix on that output of C. And you can see here. Addition and subtraction also, we have that. Likewise, multiplication, we can do it. Based on the indexing, multiplication is available. There is a direct indexing multiplication and also matrix multiplication. We can see the example with matrix multiplication, then you can understand the concept. Here I declare the value 1, 2, 3, 4 as a 1 matrix, 5, 6, 7, 8, and I am doing matrix multiplication. So this row count will be matched with this column row count. Then only we can do this matrix multiplication. We can calculate here 1 into 5 plus 2 into 7, 1 into 6 plus 2 into 8, 3 into 5 plus 4 into 7, 3 into 6 plus 4 into 8, 5, 14, 19, 6, 16, 22, 15, 28, 43, 18, 32, 50. So this is the final output of this matrix multiplication. We can see here, this value directly match with this one. Likewise, the calculation will be happen in the backend. That's it, friend. In the next video, we are going to see with some machine learning library with TensorFlow integration. Thank you.